Welcome back, everyone, to Concepts in Arithmetic. In this video, we are going to discuss the basic properties of multiplication. So, multiplication of whole numbers, at least, is defined in terms of repeated addition. So 3 plus 4 is 4 plus 4 plus 4 3 times. Okay, and we have various ways to visualize multiplication in the different models that we've discussed in this class. So for example, in the set model, we can illustrate what 3 times 4 means by thinking of 3 groups of 4 objects, as you see listed here. If we're doing the measurement model, let me scoot up a little bit there. If we're doing the measurement model on a number line, let's say, 1, 2, 3, 4, we would be talking about 3 jumps, each length 4. So let me see. 1, 2, 3, 4. So there's our first jump. 1, 2, 3, 4. There's our second jump. And 1, 2, 3, 4. There's our third jump. If we want to use the bar model, which is also sometimes useful, we'd be talking about 3 lengths, each of length 4 going end to end. And of course the product would be illustrated by the total length of all the bars joined together. Now, something that we haven't talked about yet is the rectangular array model for multiplication. Okay, so 3 times 4 can be illustrated as 3 rows of 4 objects. In this first picture, I've just got X's, and here I've got a little grid with boxes. Okay. So, the various properties of multiplication that your students will need to be familiar as they go through the K3 curriculum. They'll need to understand the multiplicative identity. Okay, 1 is a very special number when it comes to multiplication. It doesn't do anything. And this is actually pretty easily understood right from the definition. If you think of one group of 4 objects, you've got 4 objects. So that's fairly easy to understand. This is not exactly obvious from the definition, because if we think about the way we would define the left-hand side, we said it was 4 plus 4 plus 4. But if we think about how that definition would apply to the right-hand side, it would be 3 plus 3 plus 3 plus 3, right? 4 times 3. Now, the rectangular array model should make that obvious as to why the commutative property of multiplication is true, because let's look at what we've got. Yes, we've got 3 rows, each with 4 objects, but we could also view it as 1, 2, 3, 4 columns, each with 3 objects. So the rectangular array model should make the commutative property clear. And then we've got the associative property of multiplication, which applies when you've got 3 numbers. Okay, you can only do the operation of multiplication with 2 numbers. The associative property says, okay, you can do the first 2 and then take the product and multiply by the third, or you can multiply these 2 first and take that product and multiply by this one. It's pretty easy to illustrate with the set model. I'm going to scale it down a little bit just so the picture is easy to draw. If we think about illustrating this, we'd have 2 rows of 3 groups of 4 objects. That's what I've got here. I've got 2 rows of 1, 2, 3 groups, and each has 4 objects. On the right-hand side, well, I'd have 6 groups of 4 objects, 1, 2, 3, 4, 5, 6. Okay. I didn't actually tell you what this last one was. The fourth property is the distributive property. Okay, the distributive property combines multiplication and addition. And it's very useful for doing mental math. And it takes advantage of the place value. Okay, so let's say you had to do 4 times 12. Well, break it up here. Do 4 times 10 and 4 times 2 to get 48. You can even do it with larger numbers. It doesn't have to be just a 2-digit number. Do 3 times 100 to get 300. 3 times 2 to get 6 in the tens place. That's 6 tens, so 3 times 20. And then 3 times 3, so 369. Okay, so of course you remember this, right? It goes, we distribute the 4 to each of the terms in the sum. And right here we distribute the 3 here, here, and here. 360, and then finally 9. Okay, so that's the basics of multiplication.